Okay, hi. We're here to talk about having big ideas at a small company and how we've managed to keep our continuous delivery processes both productive and improve them as we've gone through a period of growth.
It stopped working.
I'm Alex. I'm probably fine on Twitter. That's a 0, not no. And I'm a software developer, and I've been at Unruly for almost 2 years now.
And I'm Benji Weber. I'm also been at Unruly for about 4 years now. Unruly is a marketing technology company, which means that we're working on tools to enable targeted ad distribution online, and also data collection and analytics that allow or give us and our clients insight into what content is popular online and why it's popular. We've grown. We had a period of growth where we grew from about 12 people up to about 120 people while I've been at Unruly in under 2 years.
So the way we are going to set out this talk is we're going to sort of outline the processes and the way we work at Unruly, so the way we've integrated XP and continuous delivery, and then talk about the people and culture, so why these ideas actually do work in practice. We'll break then for about 5 minutes for some questions, and then after that, if we have time, we have some anecdotes about problems we've had when trying to scale up both our infrastructure and our development process.
Now, some people think that doing continuous delivery at a startup or small company is easy, but it still requires a careful and considered approach. We have ad units that are seen by tens of millions of people each day. We have the possibility of breaking high-profile publisher websites. We also have systems that are processing significant amounts of money and large amounts of data. So bear in mind throughout the rest of the talk, we're not just cavalier about this, we really think it's the best way of working. So how do we actually work? We use a development methodology called extreme programming. Hands up, who's heard of it? Almost everyone, great. So this gives us a set of technical practices like test-driven development, pair programming, continuous integration, and also team practices like having a customer in the team, having regularly improving the way we work with retrospectives and so on. But what XP is really all about is feedback loops, which Dave talked about earlier, and keeping those feedback loops as short and tight as possible. We see this with pair programming, which is really the shortest possible feedback loop for code review. We see it with test-driven development, which is a really short feedback loop for finding out whether your code actually works. We see it with a customer on the team that we can go and ask whether we're building what they want, and we hope you'll see that we also apply that in how we do deployments.
So the actual XP Explained book says, as you can see there, to plan releases about once a quarter and do iterations more frequently. We don't do either of these things, which is okay. Part of XP is modifying it when we think that it doesn't really suit our purposes. So we actually have our iterations about 2 or 3 weeks long, but these are actually just planning cycles for prioritizing what work gets done, and when we're pairing, we try and actively deploy release to production 2 or 3 times a day for each pair that's working on a project.
Our goal is to release, deliver value for the company as quickly as possible in production. So that's minimizing the time from conception of an idea, someone's identified an opportunity to make or save some money, through to actually making or saving some money in production, and bring those two as close together as we possibly can. The continuous delivery book uses the idea of value streams for this. So we go from a product opportunity assessment, find out some more about what the opportunity is, how much it's going to cost, and then move on to development, building that, and then getting it into production. We need to, though, minimize this whole value stream, not just the deploying of code into production that it's very easy to focus on. Because of the way we work, in exceptional circumstances, we're actually able to turn this entire thing around within 2 or 3 hours. So I can think of a few examples when we've done this. In one particular example, We had a salesperson send an email around to the team early in the morning. They had an opportunity for a significant campaign with a significant budget that was contingent on a feature we didn't yet have. And one of the development team jumped on that, had a conversation with the salesperson, discussed what was needed, thought about how much it was going to cost, then went off and found a stakeholder who could make a decision on whether that was higher priority than the other things we were working on. They decided it was, and then the dev team picked it up pretty much first thing in the morning. And then throughout the morning, we deployed to production once or twice, all the way to production, got feedback from the salesperson, and actually went all the way to the client to see if it was what they wanted. And then based on that feedback, we iterated and improved, and then towards lunchtime, we eventually deployed a version that they were happy with. We do this quite often. This is not the normal way we work, because it's quite inefficient to keep chopping and changing what we're working on. There's quite a cost to that context switching. But the way in which we work normally means we're able to do this if we need to. Normally what we do looks a bit more like this. Most of our development teams have, I think they all have a 2 or 3 week planning cycle. And what that means is throughout that planning cycle, members of the development team will be having regular discussions with customers. For us, we have a lot of internal customers inside the company about new opportunities that have been identified to make money, new things that we could be doing, and thinking about the cost of those. And then once in our planning cycle, we have a meeting where we get all of the stakeholders together to put all of these things in a priority order for us, which gives us a stream of work that we can work through for the rest of the time. And then on any given day, we will be picking up one of those tasks, doing a little bit of work on it, and then deploying those changes all the way to production. Then we get some feedback, either from our monitoring on our production system, that we haven't broken anything, or that we haven't caused a performance degradation, or, but also going and talking to customers, saying, this bit of functionality that we've added, is it actually going in the direction you want? And then we then iterate, deploy again, and then eventually those chunks of work will add up to the feature that the customer wanted, and they will declare it as done. So we're really deploying very regularly. And yes, for us, feature's only done when it's in production, and not only it's in production, it's delivering value. And not only that, but we can measure it delivering value, so we can see through analytics or however that people are using it that is making us more money. So it's not just that we've integrated it with the rest of our team, or even that it works. So we've thought about the first part of the value stream, getting ideas into development. The continuous delivery book has this concept of a deploy pipeline, after which I believe this conference is named, which usually has a number of steps. So you've got your code that's been completed, that gets committed, a build gets generated, we run some automated tests, maybe some automated acceptance tests, and then after which it might get promoted to different environments, have more tests run on. And the implication is that in some organizations, the promotion to other environments may be done by someone from another team clicking a button, and it has to get through all of these environments to get into production. I don't really like the concept of a pipeline as a metaphor. It was interesting to hear Dave say earlier that it wasn't intended to be like a pipe. It was a processor pipeline, which is interesting, because everyone I've spoken to seems to interpret it as being a tube. I don't like it as a metaphor because it seems to imply to me that you put something in it and then it takes some time before it comes out the other end. Pipeline typically are quite long. The other reason I don't like it is that pipelines have a fixed capacity, and there's an implication that things can get stuck at different points in it, which indeed can happen. If you have handoffs to other teams as part of your pipeline, then there's a good chance your deploy is going to get blocked at some point. So I prefer the metaphor of a gate. This fits more how we work. We've got our development environment on one side where we're making changes all the time, and then we've got a gate protecting our production environment from us deploying things that would break it. The gate's locked when our tests are not passing. But when they are passing, we can lift up the gate and let our changes through to production. And to me, a gate is just a really short pipeline, as short as we can possibly make it, where we run as all of our tests in as much in parallel as we can, so it takes as little time as possible.
So as part of this process, we try to automate as much as possible so we can keep our feedback loops as tight as possible, so there's as little manual process that goes through it as possible. So these include things like the acceptance tests, the integration tests, all the things you would expect to run during this test phase. But we ran into the case where some of our tests were taking longer than expected, or we didn't really care that much if they were broken. So what we actually did with those is we moved them out of our actual test cycle and into production as checks. What this actually meant for us was that our development cycle became tighter because we had fewer tests to run and they were less unreliable. And these things that we don't really mind if they're broken, they send us alerts. And so this is, for us, it was things like response times for performance, or making sure our users are cookied correctly during in our targeting systems. We call this NAGDD, so NAG is short for Nagios. We use Nagios for our alerting, but it's also nagging you to fix something in the sense that this is broken, fix it immediately. And it allows us to get quite quick feedback about what our system is doing in production.
So we're continually deploying all the time, as I've mentioned, and to us, we're doing this so frequently, it fits into the normal feedback cycle we get from our tests. I expect most of you are familiar with test-driven development. But so for us, the process is we write a failing test, first of all, we see it fail, then we write the smallest amount of code possible to make that test pass, we see it go green, then we'll do some refactoring, because we only wrote the smallest amount of code needed to make it go green. And then we'll see the test passing again, and at this point we have a decision. We can either go back and do some more refactoring, which typically we should, or we can write another failing test and go around the loop again, add a bit more functionality. Or, and typically we'd do this maybe once an hour or so, deploy to production. And after deploying, we can then get feedback from our production system and from our customers with the work that we've done so far, and use that to inform the next test that we write. A key aspect of this is that it's synchronous for us, so we don't go on and write the next failing test until we've finished deploying and got feedback from our deployment, because we use that feedback to inform the next test that we write. And as an added benefit from this, it means that we have strong motivation to keep our deploys fast, because otherwise we'll sit around twiddling our thumbs all day. The XP book has this idea of a coffee break build, that you should be able to build your software in the time it takes to go and get a cup of coffee. And to us, that means a coffee break deploy to production, so that we can deploy all the way to production in the time it takes us to get coffee. And we like to deploy at least as frequently as we want to get coffee.
Which in practice is a lot of coffee.
An interesting consequence of this is that we found we don't actually need a continuous integration server. It can be useful for some things, we use it for some projects, not for others, but because it's synchronous, it doesn't really matter whether we're handing that off to a server or if we're triggering it locally.
So since we don't use continuous integration servers and we do all of our deploys manually from our workstation, we've actually removed the ability for the business, so in this case our customers or stakeholders, to deploy, and all of that responsibility lies with us. So as part of this, when we're discussing when we've got round that deploy loop and we're going back round to feedback and we're talking to our customers and they say it's all right, then we will manually push it to production ourselves. It's not up to someone to, at some later point, decide this is okay, release this to production. And this is all part of keeping all of this synchronous. And we hide these behind what we think of them as feature toggles. In some projects they're relatively clever, in others they're just glorified if statements in templates. But it means that we can deploy to production and our customer can see what it would look like in production before we release it to the general populace. So the consequence of this is that all of our user acceptance testing is done in our production environment, and we do only have two environments, and that's development, and then when we decide it's ready, it's let through the gate into production. Our mantra for this is that when we want to test something in a production-like environment, there is literally nothing more production-like than production itself. And so even though we do run into problems with having a global organization, so if we have a stakeholder in San Francisco, you're presented with the difficulties that are inherent in time zones, but it does remove the hardness on their side if they need to connect to a VPN or something like that, and they can just use the applications they normally would and would be able to see the feature. It also means that we can get performance feedback quite quickly. So if we have, God forbid, made a mistake and we have caused a performance degradation, we can roll back quickly and get that feedback immediately. But for this to work, having an accessible customer is quite essential. So all of our development team are co-located here in London along with the majority of our stakeholders. So for us, going and getting customer feedback is literally just going upstairs and nagging the person, can you have a look at what we've just done? And we found that this is quite effective. It means that we can get opinions on the features we developed really quickly and thus keep our feedback loops tight. Yeah.
So what we're doing is not just continuous delivery, we're continually deploying our changes to production. It's not that every build is a candidate for being deployed to production. Every single change that we push to GitHub is actually deployed to production, which is a fantastic simplifying assumption because we always know what code is in production at any time. It means that deployment is really a non-event because we're doing it really so frequently. And we're so confident that we even deploy after beer o'clock on a Friday because it's that normal for us and we're deploying such small amounts of code at a time that there's very little that can go wrong. There's some cases when we wouldn't do this, but it's usually because we've been failing at doing continuous delivery. Maybe we spent a whole day working on some changes. At that point, it's quite a big, scary thing to deploy to production if we spent all day on it, and we might then leave it till Monday. But if we're doing things properly, it's really not a problem. And a consequence of this is that we don't have any branches other than in version control, other than the implicit branch that exists on each pair's workstation. We don't push any branches to GitHub because changes are continually integrated, not just with the rest of the team, but with our production environment. And those branches on the workstations only live as long as it takes for them to deploy. People often ask, what's our rollback plan? Do we write rollback plans? Do we automate our rollback in production? The answer is no, partly because it would introduce another barrier to deploying really frequently. But what we find is with very small changes, we're very unlikely to break anything. And when we do, we know exactly what we've broken, and then we can simply fix it and redeploy or roll forward. If for some reason we didn't, we'd just revert the change and deploy it again. So we'd still maintain the state that the latest code in our version control repository is what is in production.
Cool. So that's the way we work, and I'm just going to talk about the people and culture that we try and encourage at Unruly that makes these processes just gel together and make them effective. So siloing is bad. This is a deliberately inflammatory slide title. Siloing is bad if done badly. So here is an organization, you've grown up and now you've decided, right, we have some different concerns, let's create an operations team, a UX team. This diagram is particularly unrealistic because there are far too many testers relative to developers. But developers are in grey, and this becomes important a bit later. So trying to keep our loops synchronous means that we really don't want to be handing off work to another team, basically ever. So we want to keep all of our feedback and we want to wait for it right there. And if we're passing over work, so whether it's user interface work to the UX team or operational concerns to the ops team, we're losing at continuous delivery if we do that, in our opinion. So we could have split down into product teams. So each product has their own UI person, has their own operations person, DBA, product manager. If you're lucky, you get a developer at the back. But this is still the same problem, just on a smaller scale. You're still handing off work and so you'd hand off work and go and do the next piece of work, which we're trying to avoid. So the way we do things at Unruly is we really emphasize generalism over specialism. So we encourage all of our developers to work full stack, so right from the top to the bottom. And that's not to say we don't have specialists, but it's the role of our specialists to help our developers do what they're doing better. So say, for example, if there was a story with a significant piece of UI work, it wouldn't just be handed off to our UX engineer. It would be, they would come and pair with our developers, or there would be discussion, and it's the job of the developers to write and deploy that feature. So it's almost as if these specialists are almost in a consultation-y role, but they are still embedded in the teams, and it means that we don't have to pass off work to them, because it's ideally the same pair seeing the story through from start to in production. So when we scaled up and we went from around 3 to about 30 developers, we did this with our teams, and this was good. But as our product set increased, we still had a product team, so this was essentially a team of product managers, and they would maintain the stories, set priorities, and pass it off to the teams. And this quickly became a bottleneck as well. They knew why the stories were being implemented, and they were just passing things off to the developers. And so in the same way, we've now integrated that product team into their respective product teams. And what this means is that in a similar way, developers are encouraged to take ownership of the stories that they're involved in. They're encouraged to do story research and generally have a full view of everything that's upcoming. And so this is, to us, a logical extension of collective ownership as described in XP practices. But it's not just codes and tests that we're sharing here. It's operational requirements, it's support. So we share our support engineers across all of our teams.
So as part of this, the developers themselves are on call. If something goes wrong with the production system, they're the ones who get woken up at 1 a.m. in the morning. And because they have this responsibility of looking after the production system, they can also have the freedom to deploy as frequently as they want and whatever they want, because they're the ones who'll feel the pain if they deploy something overly complex that breaks, or if they haven't tested something properly. We also do pair programming on all of our production code, which not only reduces the defects that we're introducing, but it means that we remove code review as one of the things that might be a bottleneck in our deployment to production, because all code is reviewed at the point at which it's written. And probably the most important aspect of our team practices is that of self-improvement. We have regular team retrospectives and cross-team retrospectives where appropriate, where we look at things that have gone well and less well in the past, what we want to improve in the future, and how we're going to do that. But we also have queues of development tasks, things that we need to do to make our practices better, that we would prioritize concurrently to work we're doing for customers. And on top of that, we have 20% time where developers can work on literally whatever they want. And we found that people often end up scratching their own itches and working on things that make us more effective as part of that. So we thought we'd pause there for questions before we go into some of the difficulties we've had scaling this up. Here, front.
Hello. One of your earlier slides, you had that accelerated value stream.
Yeah.
A step in that involves you making a cost estimate. I was just wondering what that cost estimate looks like if it's a kind of 2 hours to production.
Yeah. Well, we use quite fine-grained cost estimates because we're always trying to chop things down into very small chunks, even the whole user stories. We try and keep to a day or less of work if possible. And yeah, I know there's a no estimate movement at the moment, but we're not really committing to anything when we make an estimate. It's just a guide for the business. So to us, they still have some value in doing estimates.
It's more of a helper, so if we want to decide that we want to switch that in and we have the resources available, it's more of an indicator that that's possible rather than it's too big, even if it's really important.
So, in turn, do you have projects?
How do you define a project?
I guess in the traditional sense of maybe a fairly large scoped piece of work, or something scoped at a much larger scale compared to the sort of hours or days scale that you've described here?
Not really, no. We have products, and we may have new products that we haven't built yet, that may have a business person who's looking after it, and they'll have some vision of where it's going, but we don't have projects with like timescales and that kind of. Should we have another question?
So basically, you scaled up the team from 12 to 120 in 2 years, which would imply that the bottleneck was the resources. And also by how you explained it, that you can work and deploy individually. Each very small team can do that. It sounds to me that that you have very, very good parallelization possibilities with your project. Is it true? So, do you really? So, I think I would like to know more what you're doing. What are the projects that you're doing? Because it sounds too idealistic to me that you can really do in isolation from all the rest of it, and that you can really put more people into it in a very rapid way.
Yeah, so we'll talk a bit in coming up about challenges we've had scaling up, but yes, you're right. We found an individual team working on a product couldn't really get bigger than about 10 people before some of this stuff starts breaking down, so we had to find other ways of scaling.
So that would imply that your product, so you have multiple independent products that you can work on instead of one large one. Is it
we'll
true?
come on to this in a bit. Yeah.
Hi. What's the main language that you're developing in, and do you think that that's helping you move fast and break things?
So the majority of our code base is Java. We use quite a lot of Spring as well in our older projects, but nothing extraordinary. Our more front-end oriented team tends to be a bit more modern and flexible in that they're using Node for some projects and AngularJS, but nothing groundbreaking that we'd consider actually helps us. It's just we're more familiar with those languages, I guess.
A counterexample maybe in that we tried using Scala for some new projects and found that it took longer to compile than run the entirety of the rest of the pipeline, so that was quite a big killer for this type of feedback loop. Yep.
If you would go back to, say, 60 people, how much productivity would you lose?
Well, there'd obviously be a lot of pain. I think a lot of what we do scales up and down, and it would just reduce our capacity. We would probably have to kill off products entirely. Shall we carry on? We can have some more questions at the end. Back. There you go.
So in an ideal world, we'd have been able to keep up with these processes and they will have just scaled and we would have been happy, but this isn't the case at all. And I'm going to walk through about some of the structures, some of the problems we've had scaling up the infrastructure side of our development process. So we went from a team with around 3 developers and 1 physical tangible box in the office configured by, at best, shell scripts, to now we've got several orders of magnitude more using cloud providers. AWS is our main provider, and we're using proper configuration management tools, so we use Puppet. From this point on, when I say configuration management, I mean Puppet, but there are others available. So the phrase infrastructure as code has been thrown around quite a bit, especially with how popular the DevOps movement has become. And we try to embrace this in that we treat it the same way we actually do treat our production software code, in that we try and test drive it where possible, It's not released into production if we haven't paired on it, and we want to keep a tight feedback loop in the same way, because infrastructure changes are just as likely to break something as code changes are. So it's important to have a good understanding of that in the same way. So part of the problem with this was when we started off, it was okay having our special snowflakes. Those are machines that we've configured maybe by hand, but no one knows what's on them. Maybe the person who set them up has left, and they've become production critical pieces of infrastructure. And as we've grown up and we've needed more machines, the inevitable result of this is that machine death becomes more frequent. Sometimes AWS just turns off your machines without you asking them to. But what we've done to try and mitigate this is to make our machines disposable. So it's this idea of having constantly rebuildable infrastructure.
We've been caught out in the past where we've assumed that a machine was rebuildable if we needed to because it's got its configuration management managed by Puppet, and we've been making all of our changes through Puppet. But that's simply not the case. It's never the same. Provisioning a clean machine, the only way to do that is to continually throw it away.
And so we do practice this, we call it continuous disposal. So if we are developing a feature for a project, we want to check out that when we rebuild it, the machine that it's hosted on is still rebuildable. So with our more recent projects, this is easier, and it is quite a lot less work with machines with no state. So queues and things like that can sometimes be detrimental to making this possible. So as part of that test-driven development deploy feedback cycle, the first thing we do whenever we're setting up a new product or a new project is to deploy a Hello World app. If this is a web app, this is just a single endpoint that says Hello World. But the point is that we've got something into production early and we know that we can get something into production, and then we can develop iteratively in that same way. So we don't have to worry about, we've written this lovely bit of code, it does exactly what we want, but we can't deploy it yet. And by doing this, it means that we're growing the code around the deployment structure. It's this notion of having a walking skeleton to start with. So you start with the very basics and being able to ship something, and then you can improve on it later. So we try and test drive it, but this is something we've been starting to do recently with mixed results. So in my opinion, unit testing, especially for Puppet, internally is not useful. So our stack is largely homogeneous. We have CentOS 6 machines in production and largely Fedora workstations. And where unit testing really shines is when you're trying to make things portable. So say if you're installing the right packages or things like that. And we don't need to do any of that. So unit testing our Puppet manifest becomes pointless for us. And acceptance testing is actually far more useful to us. So reasoning about the state of the machine, both internally and externally. So we've recently started using a framework called Test Kitchen. This is chef specific, but it can be mangled to support Puppet as well. And this is a test framework called BATS, which is essentially it runs some shell commands and makes sure that everything exits with 0 status. So this is just a simple redirect to HTTPS. It sounds simple, but up until relatively recently, we weren't doing this at all. So it's nice that even the really simple things, if you start off small, you can generally build around them. But we're also interested in, so this is, that was an external acceptance test. Internal acceptance tests are also interesting to us. So this is a Java port of the server spec library for Ruby, written by one of our developers during their 20% time. And the idea is that you can reason about the state of the machine from its inside. Being written in Java, it has the advantage of type safety. So you can't, for example, assert that a service is listening or a port is running, because that doesn't make sense. But one problem we did run into is when our teams grew so large that we had to split them down, was this notion of shared infrastructure. So when we had one large team, everyone owned everything, and it was fine. But after we chopped it in half, the things that were shared amongst them, so this was primarily alerting, our puppet masters, our monitoring, were shared between the teams. And what happened was, if there was an issue, people tended to assume that, oh, that's fine, the other team will fix it. And when all the teams think that, it goes broken for ages and everyone suffers. So to fix this, we created a cross-team team. They're sometimes called squads, wherein each team has a representative, and we sacrifice 3 pair days per iteration to prioritize backlog of infrastructure tasks in the same way that we do in our software development prioritization, and we chop through them. We call this squad Borat Squad internally, after the now sadly defunct DevOps Borat Twitter account. And we've had quite a lot of success with this in terms of making things easier across the team for all of our infrastructure.
This is purely shared infrastructure, things that affect all of the teams, because each team themselves looks after the infrastructure for their own stuff, but we found that there was some shared stuff that was slipping through the gaps.
So as part of a general mantra for improving this shared state, we've adopted this reduce variance, increase mean. This is it's a phrase from Six Sigma, which is an actual engineering methodology. But the general gist of it is that when you homogenize as much as possible, then you can start on making things better. So rather than improving things where they are, make it easier for yourself by making it more homogeneous. So for us, this meant bringing all of our systems under one configuration management, having one operating system across everything. Something that came out of our out of this Borat squad was actually this idea of croned code deletion. It's not as crazy as it sounds. So if we're doing continuous delivery properly, this is not an issue at all. So you go home on Friday, you enjoy your weekend, you come back on Monday, and your workspace is clean, and you've got a clear checkout from most recent version control. If we're not continuously delivering properly, then you stay on Friday, you leave some changes, come back on Monday, your code's gone. And if we're doing this properly, if we're committing and deploying in regular increments, this doesn't present an issue to us. But if we're not, it bites you, and it bites you hard. You only have to be bitten by this once to, in my experience, to actually have this, to not do it again.
So yeah, we've also obviously had issues scaling up the development teams and the products, as well as our infrastructure as we've grown. So our initial approach, as I said earlier, we found that when we got to more than about 10 people, some of our other practices started breaking down. It's difficult to have full collective ownership when there's that many people working on that many things, because there's too much for everyone in the team to fully understand and get their heads around, and too many threads of communication for everyone on the team to follow. So we knew we needed to split the teams down. So our first thing we did was to split the teams along existing product boundaries, which was fairly straightforward, because where we already have conceptually separate products, they can work on them separately, have separate prioritization sessions with customers, deploy separately, and that kind of just works. But it only worked up to a point. After that, we needed to start thinking about new ways of breaking down the teams. And we thought we'd try and take advantage of Conway's Law. Conway's Law being that organizations that design systems tend to design systems that mirror the communication structures within those organizations. So we viewed splitting teams as an opportunity to actually improve our architecture of our systems at the same time, define clear API boundaries between the teams, so that each team is free to deploy and iterate on what they're working on as much as they like without affecting the other teams. And as a benefit, we split up bigger monolithic applications into smaller applications that we can deploy separately and deal with separately. Doing this later does have some advantages. Obviously, if we'd started off in the first place building everything as small microservices, then we could have just allocated those to different teams, potentially. but defining service boundaries right when you first start and know least about the problem you're trying to solve can make it difficult to decide where those boundaries should sit. Whereas if we split things out later, then we have more information about the problem. We are kind of moving in the direction of having much smaller services, a few hundred lines of code in each that we can deploy separately. But this has been not without problems, and I'm not entirely sure where the best point is in this balance. With bigger projects and applications, it is more difficult to keep the deploy pipeline fast, get stuff into production fast, and they're more difficult for teams to understand and improve. But on the other side, if you have lots of really small services, you have a lot more complexity and the dependencies between them. The tooling is less mature for refactoring across service boundaries. The tooling is less mature for testing behavior that exists in the interconnections between services. And writing deploy pipelines is harder for lots and lots of small services that interact as well. So yeah, we've kind of got a spectrum of all different size services, and I wouldn't say it's easier at one side than the other. Another problem we've run into is runtime state. One of our applications in particular is quite bad at this, and having in-memory state that's not persisted, and the deploy has to wait for that state to drain before the system can be restarted, and that was a real killer for our deploy feedback loop, because it was lengthening that by an undefined amount of time. So this is something we've been working on recently. And we found that we've had to continually invest in keeping the deploys fast, whether that's profiling the tests that are running, whether it's parallelizing more, or whether it's splitting projects into smaller projects. It's useful that we have this synchronous deploy, because that gives us feedback in that it makes our lives painful when it takes a long time to deploy, and it forces us to decompose bigger applications into smaller applications so that we can continue working in the way that we do. Reliability has also been an issue, particularly on our automated acceptance tests that go through the user interface. What we found is that a 0.1% failure rate is really annoying when you've got 100 tests, but if you've got tens of thousands, then it's literally impossible to ever deploy. So we had to find ways around this, and basically we had to be really strict about deleting tests that weren't delivering value and were non-deterministic. We developed a little JUnit rule called quarantine rule that we could annotate our tests with if there was a test that was causing the deploy to fail non-deterministically. And what this did was effectively remove it from the gate for deploying, allow us to deploy without it because we don't know why that test is failing, but still run that test as part of our deploy so that and then spam us with the results of the test, so we know, we get feedback on why it's been failing, and then we can make a decision: do we delete the test because it's not really delivering value, we don't know how to fix it, it's going to be expensive to fix it, or do we go and fix it because now we know why it's failing? It also still failed the gate if it was failing deterministically, which meant it still provided a little bit of value.
So as part of this sharing the knowledge across our teams, we actually we try and have this focus on cross-pollination, because shared ownership internal to a team is easy if you're pairing, but when you split the teams out, you still want to keep that knowledge in exchange. So we have a series of fortnightly internal tech talks. These range from, here's this cool new technology I've been playing with, let me tell you about it, to here's this hard problem we solved and how we actually solved it. And the latter has actually been useful already, where a team has faced a problem when they've been growing or trying to adopt more volume, and then when one of the younger teams has reached that size as well, that problem has basically already been solved for them. And that means this work that they thought they needed to do has been cut out and has saved us lots of time. We also, inside one of our teams, we actually practice team lead rotation. So team lead is not a line manager, but more a tech lead, but they still have to go to loads of meetings, so it's more of a share the pain kind of thing.
And then this is something that we've been struggling with more recently. the trade-off and balance between collective ownership and freedom. We like our teams to be empowered to choose the technologies that are best for the job, whatever they're trying to build. But on the other hand, developers love choosing the latest and greatest technologies that are hot at the moment, top of Hacker News, particularly the JavaScript developers. But this kind of causes problems with the way we work, particularly, again, going back to collective ownership. If every new thing we start, we use new technologies for it, then it's very difficult because there's a lot of technologies in use in the team. It's very difficult for everyone in the team to understand all of those technologies to a deep enough level to work effectively. So we haven't really got a great answer to this. We have a lightweight process in place at the moment where upon adopting any significant technology, we have to go and review what the other teams have been doing and using for similar things. But it's something that has been causing us pain, particularly recently. So as we wrap up then, I thought we'd summarize some of the unusual things we do. We've lost something off the bottom, I think. But we do continuous deployment, and we're continually deploying our changes to production. We do that synchronously, so we wait for feedback from it before we go on to the next thing we're doing. We don't need to use a CI server, although we use it for some things. And the one that's gone off the bottom is our cron code deletion that we're particularly proud of, deleting our code over the weekend.
So to just sum up everything, the way we do things at Unruly, and we've managed to keep going even though we've scaled up, is keeping our development pipeline short, so keeping it as this metaphor of being just a gate. That way we can get our feedback fast, we can iterate quickly and deliver value early, and that's what the business needs, and that's what makes us happy as well. Thank you for listening, and does anyone have any more questions?
In your pipeline, do you do between services integration tests, or is it just the black box test on one service to go to production?
So you can answer this one this morning.
Yeah, we have a few. Most of these different services we have are fairly decoupled. But particularly with, say, we have a system that is used to configure adverts, and we have a team that's working on the adverts themselves and targeting and things like that. And we have tests. Both teams have tests that check that the integration there is working. In some cases, we would even spin up vagrant images as part of the deploy and run tests on those. And we've been considering spinning up actual EC2 servers to simulate our production environment as part of our deploy.
In between these projects, there are generally quite well-defined APIs, so the teams on either side can almost fake their own data because they know what they'll be getting to and from and test on that level.
I've got two questions, and the first one would be, given you don't use CI servers for deployment, how do you guarantee a clean build environment? For example, not having minor versions, for example, use Java. Minor Java revisions could be enough to affect the build sufficiently that on deployment it's broken. How do you take that into consideration?
By applying the same principles to our development environments as we do to our production environments. Using configuration management, throwing it away, reapplying it cleanly, regularly. And it's not to say that we can't run tests that aren't on our workstations as part of the deploy, it's just that we're controlling it from our workstations.
Okay, that makes sense. The second one is with, talked about DevOps callout. How does that model in terms of feeding back into your loop for development, i.e. repaying any tech debt incurred as part of that, if you don't repay it immediately, and also how does that work in terms of, well, very directly payment? Do you pay your guys on a call-out basis, or do you, is it part of the job to be on call?
It is very much part of the job description to be on call. So in one of the teams we do month on, month off, and it's just rotation. People can volunteer if they want, but that never happens.
But we have very rarely do we actually have production problems that wake us up in the night. Each team gets to decide on what is important enough to wake them up. And they're extremely motivated to fix things that are waking them up because they're getting woken up. And it really encourages us to make things very simple, and wherever possible, make production things someone else's problem, like Akamai or...
We like to call this because they're writing the code that's going to wake them up, they have to basically behave responsibly when they're writing the code. So you won't write bad code if you know it's going to wake you up in the night.
I was just wondering to what extent you use analytics and monitoring to provide that feedback, that fast feedback?
Quite a bit, do you want to...
So the idea being, especially in the NAGDD, which we talked about, is we very often write checks first. So one of the examples I talked about is we defined acceptable thresholds for response from a service, and if it's slow, then we go in and modify that. But we view that in the same way as we're writing a test. So it's just a test that happens to be outside of our feedback loop, and for varying levels of alerting. So if it's a not particularly important surface, if it just causes a slight degradation rather than outage, that can be fixed later on. But yeah.
We'd also use this for features. So I think recently Alex's team were working on a extension to our targeting capabilities, and they first of all wrote Nagios tests for what they were expecting, deployed those, saw them going red in our monitoring environment, and then deployed the code that made them work. So it's kind of the same sort of feedback loop. It takes a bit longer, but it means that then we have that as a check in production as well. And there's no reason that any automated test can't also be run as a test in your production environment.
It's just like we almost view our alerts as constantly running tests in the background, so we treat them the same way.
Hi. I'm just wondering, in terms of the volume of your work, what percentage is back end, what percentage is front end within the products?
It varies considerably per team. We have a team that's almost entirely front end, working on the ad units and other front end features that integrate with publisher pages. Then the other two teams is probably around 80-20, something like that percent.
And do all of the methodologies and the flows that you showed, do they work equally with the back end and the front end work, or are there slight differences?
Do they both work equally well for the front end and back end? Some things are actually easier on the front end stuff. A lot of our front end code has the fastest deployment cycles.
They also have the advantage of, until very recently, they had no infrastructure at all. It was all basically served by S3.
Sorry, one last question. Just you mentioned the continuous disposal.
Yes.
If you're rebuilding servers relatively quickly, how do you re-reference between different server nodes? I mean, are you using aliases sitting on load balancers in front of servers and then swapping the servers out behind the load balancers?
So we don't do that across the board at the moment, though we'd like to. The services that we've implemented that for, we are using DNS to load balance between them, and as part of the setup, we go on, add a new record and add it into rotation and take an old one out. So as far as our products in production are concerned, they don't notice. They just...
Thanks.
You mentioned that that the requirements are owned by the team.
Yes.
Do you still have a separate business, or is the team the same as the business?
We do have a separate business, yes. So most of the company is not in the development team.
Okay.
We have a product manager per team, who again is part of that team, per development team. And again, their job is not to find out all the requirements. Their job is to facilitate the developers going and talking to the customers and finding out what we need to do and talk about how much it's going to cost and so.
Okay. So by and large, the process is that if, say, a salesperson or an internal customer wants a feature developed, they will add, we use Trello for our project management, they'll add a card and then they'll get prioritized, assigned a developer who will do the story research and so on.
So my question is still that what are the dependencies between the teams and the work? So do you have cross-cutting projects which would need multiple projects to work on something? How do you work on general architecture decisions? What are the integration patterns between the different services? What is the minimum level of monitoring that you will need to have around the feature spanning across multiple projects, or you don't have dependencies at all between them?
We try and minimize dependencies between teams as much as possible. They do happen sometimes. Occasionally we'll have people pairing cross teams, so one team will one member from one team, one member from another team will work together to, say, change the API boundary in some way.
But that still sounds, so don't you have a problem with local optimization?
Local optimization? I expect so, yes. We don't have anyone really looking at the design at the level across all of the teams, and that may be something we need as we get even bigger. But yes, there is a trade-off in allowing each team to operate freely and do things as they want. May not give the optimal design across all of the teams. I can see that. It's not been a huge problem for us so far.
So back to my original question, that how much is it because of the domain that you can do it, you're allowed to have so much isolation and freedom between the teams, or you think it's applicable to any random enterprise?
I think it will vary. Some aspects of what you do are pretty fairly universal. You can apply anywhere. Some you can't. But it's really about the people you've got and what you're actually building, and you need to design your process around that. I mentioned that the continuous improvement, and our process is continually changing. We're trying to make it better all the time, and our process is an adaptation to the people we have and what we're building. I would agree on that completely. So yes, it's not going to look exactly the same elsewhere, but I think you could apply a lot of these principles to it. And the key thing is getting feedback as fast as possible on everything you're doing.
It's the last question.
Hi. Did you bring experience from anywhere else into this, or did you learn all of this as you went along?
The founders had a certain amount of experience and preferred working in this kind of approach, and we've kind of kept it as we've grown. Personally, no, I came from a company which did almost the opposite of this, and it took weeks to deploy things, and even days when something was down in production. So they were that risk adverse. But the founders kind of started this from the first 2-3 people in the company, and we've just evolved it as we've grown. I think it would be a much harder problem to introduce it in a company that wasn't doing it already. I think
so we don't do it perfectly. There are, as much as we'd like to say, we don't let people specialise and specialists help developers. There are sometimes edge cases where work needs to be done, and particularly if the development pairs are under heavy load and they can't just handle all the tasks. Sometimes the specialists will take on tasks themselves, but this is normally the exception rather than the rule.
Not everyone wants to work in this way either. We've had people issues where it hasn't fit with how people want to do their work. Yeah. I think we have to leave it there, but thanks everyone for listening.